Assalamu alaikum, my dear students. Hope you are well by the grace of Almighty Allah. Welcome to NIVS Homeschool. This is Muhammad Emdadul Haque, Assistant Teacher of Mathematics, National Ideal English Version School, Day Shift. Dear students, today I am going to conduct a higher math class of class 9. Dear students, our today's topic is exercise 1.1 question 15. This is our term is half yearly and lecture number 10 and homework number 7. Dear students, I will solve question 15 from exercise 1.1 today. To solve this question, at first you have to know the number of elements of a set. As if a set is finite set, we can determine the number of elements of the set by counting. Okay, dear students, so let us see. Suppose A is a set. A has elements A, B, C, D, E. So if we count here the elements of A, 1, 2, 3, 4, 5, it means that A contains 5 elements. So number of elements of A we can denote by N A. NA means the number of elements of a set A. So here NA equal to 5. So NA means the number of elements of set A. So if B is a set, if B is a finite set, then number of elements of B can be denoted by NB. So number of elements of a set can be denoted by n of that set, n of that set. Okay, dear students, so we have to know this to solve question 15. Dear students, question 15, now see here, prove that if A, B, C are finite sets, it means 3 sets A, B and C are given here, and these sets are finite sets. As these sets are finite set, we can determine the number of elements of this set. Here we have to prove that number of elements of the union of A, B, C, it means N A union B union C, it means number of elements of A union B union C is equal to number of elements of A plus number of elements of B plus number of elements of C minus number of elements of A intersection B minus number of elements of B intersection C minus number of elements of C intersection A plus number of elements of A intersection B intersection C. We need to prove this. Dear students, to prove this, we need to know the proposition 9. In our previous class, we have learned about proposition 9. Proposition 9 means if A and B be two finite sets, then we have proved that number of elements of A union B is equal to number of elements of A plus number of elements of B minus number of elements of A intersection B. We have proved this, and this is our proposition 9. In this case, the set A and B are finite sets. Okay, dear students, now if you notice this question with question 15, it means if you compare these two, just you will see that this formula is proved for only two sets A and B, but in question 15 3 sets given here A, B and C. It means that this question is extended form of proposition 9. So we can solve this question 15 by using proposition 9. Okay, dear students, so let us see the solution of question 15. Solution. We can write here number of elements of A union B union C. To prove this, at first we have to write we know. Number of elements of A union B is equal to number of elements of A plus number of elements of B minus number of elements of A intersection B. According to proposition 9, I have written this as formula. So, we can write here number of elements of A union B union C. As we know this formula for two sets, so we have to compare, we have to consider two set as one set, So, if we consider B union C as B and if we consider A as A, then here will be two sets. One is A, another is B union C. Then we can apply that formula. So, we can write here number of elements of A union B union C. Here B union C we are considering as one set, as only one set, B union C. So, here is a set and this is also another set. So, we can say applying this formula we can write here number of elements of A plus number of elements of B union C minus number of elements of A intersection B union C. So, what should we do now? First one is number of elements of A and then we can write here number of elements of B union C. So, we can apply this formula again here. So, we can write here number of elements of B plus number of elements of C minus number of elements of B intersection C. Now, we have to go to next part, that is number of elements of A intersection B union C. Dear students, if you notice here, from this we can write number of elements of A intersection B union A intersection C. Now, you have to understand that how can we write that? Dear students, in our previous class we have learned some laws of set. In that class I have told you the distributive law of sets, The distributive law, two law I have told. One is A union B intersection C equal to A union B intersection A union C, and another was A intersection B union C, that is A intersection B union A intersection C. Okay, dear students, so we can say applying distributive law, this matched with this part, So, from this we can write this. It means that using distributive law we can write A intersection B union C is equal to A intersection B union A intersection C using distributive law. Now, we have to write the next line. Dear students, now if you consider A intersection B is a set and A intersection C is another set, then what will you get? You will get here, as here is union, so we can apply proposition 9 here again. So, apply proposition 9 here. Number of elements of A plus number of elements of B, number of elements of C minus number of elements of B intersection C. As we can't do anything here, so this will remain same, minus. Here we can write now number of elements of A intersection B, number of elements of A intersection B plus number of elements of A intersection C minus number of elements of A intersection B intersection A intersection C. I have taken here third bracket for this minus sign. When we will remove this bracket, then the sign of the terms inside the bracket will be changed. For this I have used here third bracket. Now I will remove that bracket. Number of elements of A plus number of elements of B remaining here plus number of elements of C minus number of elements of A intersection B intersection C, number of elements of B intersection C. Now what is remaining here? Now we have to go to here, so we can remove the third bracket. Now plus and minus is minus number of elements of A intersection B, plus minus is minus, plus minus is minus number of elements of A intersection C, we can write as C intersection A. Both are same. When we will do the intersection, just we will take the common elements. For this, the value of A intersection C and the value of C intersection A will be same. But you may ask, why I am writing C intersection A, but in this line I have written A intersection C. We can write any one, but in the proof here is given, we have to prove C intersection A. For this I have written C intersection A. Okay, now go to the next one. Here minus and minus is plus, then number of elements of A intersection B intersection A intersection C. It means that we are taking the intersection of just three sets A, B and C. We are taking the intersection of three sets A, B and C. This is just intersection here. A intersection B intersection C. So I have written the total here, just I have to arrange now. Number of elements of A plus number of elements of B plus number of elements of C. Then minus number of elements of, at first I will write A intersection B, then minus B intersection C, number of elements of B intersection C, minus number of elements of C intersection A, and then plus last one, that is number of elements of A intersection B intersection C. So I think proof is done. You can match with the given question. Number of elements of A, number of elements of A, number of elements of B, number of elements of B, number of elements of C, number of elements of C, number of elements of A intersection B, number of elements of A intersection B, number of elements of B intersection C, number of elements of B intersection C, minus number of elements of C intersection A, minus number of elements of C intersection A, and the last one is plus number of elements of A intersection B intersection C. So we can write here number of elements of A intersection B intersection C. Okay, dear students, I hope you have understood how to solve this question. Okay, dear students, now I have given you a homework. Your homework is exercise 1.1 question 26. From exercise 1.1 question 26 you will do as your homework. To solve this question, all the necessary information or the basic information we have discussed in our YouTube class and in our live class also. So do your homework properly, submit your homework on next Saturday from 9 AM to 3 PM in the school. Keep practicing at home, abide by your parents, stay home, stay safe. See you again. Till then, Assalamu alaikum.